Okay, network actions. Um, let's now discuss network actions and how they differ from the traditional actions that you are accustomed to with 521 and 522. And to understand the difference between them, I'm going to give you a quick crash course in modeling. There are basically two general approaches to network optimization. And these are generally referred to as the top-down approach and the bottom-up approach. The fundamental challenge with the bottom-up approach is that the number of possible combinations of actions. In this case, I listed out the common work items that UDOT would normally perform. As you can see, the bridges would be gone long before I could arrive at my best answer, or the best possible solution for my network, unless I was willing to use a supercomputer or make certain basic assumptions. Because at 4,000 years, there's too many combinations to consider all of them equally. For the top-down approach, using a single average project is probably too simplistic. So instead, consider where we choose an action from each of these columns. If we define preserve deck as our generic deck preservation treatment, then this calculation can be made in a more reasonable amount of time. We've significantly reduced the number of combinations. So actions which are built using the top-down network analysis mentality, that are made to be generic and used at a network level, can be distinguished from the other actions, your bottom-up or work candidate actions, by checking the network level box. This will enable this action to be used in the network policies, which is what we're going to discuss next, network policies. So again, this is the generic 64 combinations that I had before of preserve, rehab, and replace, or do nothing as my options for deck, super, and sub. Now, so these are the same generic assumptions that we discussed earlier, but notice that we can reduce the number of combinations and thus computation time even further by ruling out combinations that we would never consider. We would never pair a deck rehab or a deck preservation with a superstructure replacement. So in this example, in my state, there's no substructure preservation treatments that we would consider. By being able to define what combinations I would actually use, I reduce the number of combinations further. And the network policies allow us to do exactly that, to define the combinations of actions to be used in optimization. You can go up to 3 levels deep of actions, and there's no limit as to how many treatments you can put in each branch of the tree. But remember that everything you add is going to add runtime to the analysis. So you add branches through the menu at the bottom, and it's typically a good practice to name the tree after the root action, but that's not necessarily required. In this case, I have it named preserve deck. My root action is preserve deck, and then you'll notice from there, as I had drawn out earlier, there's the rehab super or paint super as the next possible options, and then also repaint super, and then there's additional paint sub or rehab sub follow-up actions to those, 3 levels deep. To limit the number of conditions even further, you can add to limit the numbers of combinations even further, you can add conditions based on any database field for when this work should be considered. This way the optimizer doesn't recommend preservation work on a bridge that has like a deck rating of a 3, for example. And then, because the optimizer will recommend an awful lot of projects, you have the option to define project categories that you would consider this work to be. You would consider this combination to be preservation work, or this combination to be rehab work, or you can define other categories. But this will allow you to sort out your projects and categories by categories later after the optimization returns its results.